dangerous in their life. How many?
Iron is a silvery white or grayish metal. It is ductile and malleable. Ductile means that it can be drawn into thin wires, and malleability means that it can be hammered into thin sheets. It is one of only three naturally occurring elements that is magnetic. The other two are nickel and cobalt. Iron has a very high tensile strength. Tensile means that it can be stretched without breaking. Iron is also very workable. Workability means that it can be hammered, stretched, shaped, formed, and otherwise worked in a different metal to get into a desired shape or thickness. Its chemical property is that it is very active and it readily combines with oxygen in moist air. The product of which is called iron oxide, also known as rust. Iron also reacts with very hot steam and produces hydrogen gas. It also dissolves in most acids and reacts with many others. This element can always be found in the earth's crust, the soil, and in rocks. It's usually combined with other strong metals to make appliances like tools, weapons, steel, and other materials we see daily. It is very important for microorganisms and people because it is used to make hemoglobin, which makes oxygen in our body circulate. However, iron is very hazardous because it may react to the things in the environment and may cause illnesses if we make contact to it.
Cobalt is a silvery white metal that is lustrous, hard, brittle, and ferromagnetic. It is similar to iron and nickel. Cobalt reacts with oxygen but does not catch fire unless it's in its boundary. Cobalt also reacts with other acids to form hydrogen gas, although it does not react with water when it's room temperature. Cobalt may be obtained through nickel mining operations as a byproduct of refining. Cobalt may also be found in manganese nodules when the hot core of the earth meets the cold ocean water. Cobalt may be used in superalloys. Superalloys are alloys that retain their physical chemical properties and not rust when exposed to high temperature and high stress. Superalloys are normally used for planes and gas turbines. Cobalt may also be used for magnetic alloys, which can be used for electric motors and the like. When we inhale too much cobalt, there is a high possibility of respiratory diseases such as asthma and pneumonia. Uptake of too much cobalt may lead to heart problems, vision problems, thyroid damage, and nausea and vomiting.
Nickel is a silvery white element that belongs to the transition metals group. This means that nickel is metallic and it has the properties of a metal. Nickel is hard, malleable, and ductile. It is a good conductor of heat and electricity, and it is also magnetic. Nickel is not very reactive. It reacts very slowly with the oxygen in air at room temperature, and it reacts very slowly with hydrochloric acid. Most nickel on Earth is inaccessible because it is in the planet's iron-nickel molten core, which is 10% nickel. It has also been calculated that the total amount of nickel dissolved in the sea is 8 billion tons. The major use of nickel is in the preparation of alloys. An alloy is a metal made by combining two or more elements, especially to get greater strength and resistance to corrosion. Nickel alloys are characterized by strength, ductility, and resistance to corrosion and heat. About 65% of the nickel consumed in the Western world is used to make stainless steel. The remaining 23% of consumption is divided between alloy steels, rechargeable batteries, coinage, foundry exposed to nickel by breathing air, drinking water, eating food, or smoking cigarettes. Skin contact with nickel-contaminated soil or water may also result in nickel exposure. In small quantities, nickel is essential, but too much of it can be a danger to human health. An uptake of too large quantities of nickel can lead to asthma, heart disorders, respiratory failure, birth defects, higher chances of development of lung cancer, nose cancer, larynx cancer, and prostate cancer.
Copper is an orangey red color. It is very malleable and ductile. It is very reactive to oxygen and it tarnishes when exposed to different sulfides. Very little amounts of copper can be found in distorted cubic crystal chunks. Larger amounts can be found from copper ore, cobalt, and chalcocite. This element can be used in construction as it is good material for fiber. It is also used for making metalware, brass instruments, coins, and wires. It can be found in our food and water that can be good for our bodies. Overexposure can lead to many dangers like irritation of the mouth, nose, and eyes, headaches, stomach aches, dizziness, vomiting, metal, fever, and diarrhea. Intentionally high intakes of copper can lead to liver and kidney diseases and sometimes death.
Zinc is somewhat less dense than iron and has hexagonal crystal structure. The metal is hard and brittle at most temperatures, but it becomes malleable between 100 and 150 degrees. Most zinc production is based upon sulfide ores. Zinc burns in air at high red heat with evolution of white clouds of the zinc oxide. It is a natural component of the Earth's crust and an inherent part of our environment. Minerals and metals are mostly obtained from the Earth's crust. It is used in making alloys that have many industrial uses. It could also be used in making jewelry. An alteration in zinc resulting in either above or below normal levels. High levels of zinc may generate from neurotoxicity and neurodegeneration by interfering with the normal functioning of ligand-gated ion channels.
Silvers have very high melting point. They have a very metallic look as well. They can have different textures depending on how they were processed. Silver can usually be found in silver mines, and they usually take their native form where they're not as solid as they usually are and metallic. Silvers can be used as decoration and for design for various objects and things that we use in our lives. They are also found in machines and we used to make sure that the machines work properly. Silver in its native form is harmful to human health. When ingested, it could potentially poison the person who ingested it.
Gold is a transition metal into physics. Physically, it is a soft yellow dust, corrosion-resistant element. When you say corrosion-resistant, it means that it isn't affected by corrosion or it repels against corrosion. It is also the most malleable and ductile metal. Gold is chemically inactive, which means it is extremely resistant to chemical action. Gold does not react with the non-metals except for halogens, with which it forms halide. You can find gold in seawater and is usually associated with rocks and granite, which you can find there. The largest known deposits of gold is located in Africa and India. Gold has many uses. For example, it can be used for jewelry like rings, pendants, and jewelry. Also, it is used for investment purposes like in gold bars, in automotives, and in dentistry.
reactions and it can cause problems to your kidney and liver. Good evening. I'm here to interview you about the modern uses of transition metals, such as nickel, iron, and the like. So metals are very important in your field as they serve various purposes. Is it alright if you shared what these specific purposes are?
Okay, my field is construction, and we use steel to reinforce, as steel is a component of concrete. Basically, we use reinforcing steel in concrete structures. So what they do is, because the strength of the steel is tensile, it increases the tensile capability of building performance.
Okay. So, do you happen to be aware of the physical and chemical properties of these metals that aid in the usage of the materials?
So chemical, I'm not so aware of it. But physical, again, like what I've mentioned, the physical strength of steel is tensile, which is the stretching capability. It has very strong tensile strength. Unlike in concrete, the strength is compression. So when in a concrete structure, you mix the two together, one is good in compression, the other is good in tension.
Okay. So, in speaking of chemical properties, does the chemical reactivity of these metals affect the materials and their purposes?
Yes, because steel weakens with corrosion. So we have to protect the steel from corroding. Now, when reinforced steel is exposed to elements such as the air and water, it actually corrodes very fast. But when we put steel inside the concrete, since there's no oxygen, it doesn't oxidize. The corrosion process is actually diminished.
Are you aware that steel is an alloy of different metals?
Yes.
If you use the metals separately, not as an alloy, as steel, do you think they would still serve its purpose properly?
It will serve other purposes, but maybe not.
What kind of purposes would they serve?
For example, gold in pure form is a jewelry, but jewelry is not used in construction.
But how about construction purposes like iron or nickel or cobalt? Do they have any purpose in construction?
Yes, but again, the reinforcing steel used in construction is a mixture of different metals, so it becomes an alloy.
Are there any other kinds of metals that you use in construction?
Yes, aluminum.
Aluminum.
We use aluminum. We use iron. We use that's what I'm basically familiar with as of the moment.
So, iron is not an alloy.
Okay.
In what way does it serve its purpose in construction? Since it's not as strong as other alloys like steel.
Iron in its pure form has its physical and chemical strengths, which is also used in construction. So we actually get the strength of these alloys and plug it into our formula, and we can actually compute how much iron do we need at a certain structure.